record on the stream. Good morning, everyone. This is our entry for Geospatial Innovation Challenge. So, our project helps people to detect freak spots in public spaces. For this demo, we are using a Deep Lens version 1.1 and an object detection model, which was created using YOLO v3 framework and COCO dataset.
Initially, our project would have encompassed a little bit more. We were going to make 3D scans of the room that this was in, like a library or a computer lab or such. But obviously, with the current situation, we can't really test our device or system on public areas. So we have had to keep that in mind. And we've also had some communication difficulties as I'm sure anyone could expect. We're currently 10.5 hours apart. So it's a little bit weird when it comes to communication. And we have to mainly go with texting, or when we're both awake at the same time, video calls.
And yes, the internet connection in India is not that great. So this video gives a small demonstration of how the code works. So this is the table area we are using for demo. And that is the deep lens that we'll be using. There are 3 lights, as you can see. The top light represents that the camera is currently capturing the footage. And the second light represents that the deep lens is correctly connected to the internet, sending data. And the third light represents that it is having power supply. The output goes to that screen. And as you can see, the chairs are drawn with green boxes representing that the seat is currently available. When I go and take the seat, it's going to wait for a few minutes to confirm that I have taken the seat and I'm not just passing by the seat. So after waiting for a few minutes, it's going to show a result. As you can see, it's not showing that I'm sitting there or a live footage, because that's going to be against the law for public places. Therefore, we can't really show the footage, and we use images, pre-recorded images, to showcase if the seat is available or not. After a while, when it has confirmed that the seat is taken, it turned that area red, showcasing that the seat is already taken by a person. And the right seat is not taken. Therefore, that seat is green. Now the next footage is going to allow us to see how the code is actually functioning in its background. So this is the table area. In the background, it runs an object detection model, and it draws squares around the objects it detects. And it also detects the collision between the squares. So if there is a collision between the square drawn for a chair and a human, it sees if the collision has lasted more than 1 minute. And also, what is the collision percentage? How close or overlapping are the squares? And also, it uses the factor of the height of the human being to the chair to see and estimate if the person is sitting or not. It accounts for all the factors to see if the person is actually sitting and to see if the chair is occupied.
And here are a couple images of the 3D models. Again, this was part of the project before it had to be, unfortunately, scaled back a little bit. At the top left, that is a 3D scan of one of the computer labs at McDonnell Douglas Hall. I went around and took a bunch of pictures at different angles, and putting it into the Autodesk recap software, it made a point cloud, which is the image at the top right, where each one of those points is a shared point between multiple images, and that the program was able to put it in a 3D space showing actual depth by combining the set of 2D images. And from there, you can digitize it. For example, on the bottom, I have an overhead view where I drew lines around the tables and the chairs and the computers to give an estimate for the software of where people might be sitting. And you can do this at any angle as part of the initial plan, but this is just top down because it's a little bit easier to see.
So the usage of the software. It could be used to see if there are seats available in public libraries, college libraries, and other public places. It could even be used to run predictions and other models to see where the probability of whether a seat is going to be available on a future date or not. And it could also be used to study patterns by institutions to imply new rules or to set up or change closing and opening times. Currently, this software runs on DPLANs, Raspberry Pi 4, Raspberry Pi 3, and it could also be used on other Internet of Things devices. And and we haven't used any Amazon AWS DPLANs SDK so that we can actually use the software on different platforms and it's not restricted by a single device or company platform. And is also not prone to the updates of DPLANs SDKs because most of the SDKs and the functions are coded by us. Thank you.